All right, let's take a peek at lesson number 2, which is problem solving with sets and Venn diagrams. So in this lesson, we are going to be kind of going a little bit deeper into Venn diagrams, or looking at a couple of different scenarios with Venn diagrams, as well as kind of delving into really being sure we're confident in identifying the number of outcomes in a specific set. Okay, so just as a reminder, we use the notation N of A to tell us how many items or elements are in a set. Okay, so if I have the universal set, if the universal set for this question is the positive integers from 1 to 20, then we're going to write in set notation the universal set, the even numbers, the odd numbers, and multiples of 5. Okay, so just again, practicing our set notation. So if I've got the universal set, so the universal set is the list of all numbers, positive integers from 1 to 20. So we're just going to list them all. All right, so there we have all of the integers from 1 to 20. That's the universal set. Then the set represented by E is to be the even numbers from 1 to 20. So that is 2, 4, 6, 8, etc. All right, so there we have the even integers from 1 to 20. O is the odd numbers from 1 to 20. So that will be 1, 3, 5, and so on. Okay, so there we have the odd integers from 1 to 20, and F is the multiples of 5. So these are 5, 10, 15, and 20. Okay, if we want to now determine the number of elements, so how many elements are in each of those things, so in the universal set, well, there are 20 items there. The number of even numbers that I have is 10. The number of odd numbers that I have is 10. And the number that are multiples of 5 is 4 of them. Okay, so that's just kind of set notation review, determining the number of elements, and then now we're going to draw a Venn diagram. So recall that a Venn diagram, we draw a rectangle around the outside to represent the universal set, and then inside we put circles to represent our other sets that we're talking about. So we know that we have the evens and the odds. We have to think about whether those are disjoint or not. So we know that they have no elements in common. So I would have the even numbers here and the odd numbers here. Those are disjoint. And then I need to think about the set that is F, or the multiples of 5. And what's interesting here is there are a couple of elements of that set that are even and a couple that are odd. So we have some overlap, and we haven't looked at this yet. So we have some overlapping sets that look like this. It kind of looks like Mickey Mouse. Okay, so what I know is that the elements that are in the set F that are also even are 10 and 20. And the elements that are in F but are also odd are 5 and 15. Okay, and then the other even digits that haven't been listed in that set yet are 2, 4, 6, 8, 12, 14, 16, and 18. And the other odd numbers are 1, 3, 7, 9, 11, 13, 17, and 19. Okay, so those are the sets that we've talked about. Then the elements that are in the universal set that are not already accounted for. So there will be none of them because everything is either even or odd. So they are already in that circle. So there's nothing that would be outside in this area of the universal set because everything is accounted for here. We also have no numbers out here because these multiples of 5 are either even or odd. Okay, here's another new word. So the word is mutually exclusive. So two events are considered mutually exclusive if they cannot occur at the same time. Are there any events that are mutually exclusive in our example above? Well, yes, the evens So the even numbers and the odd numbers are mutually exclusive because you can't have a number that is both even and odd at the same time. All right, let's look now at a dice question. We'll do lots of these kind of dice questions, dice and cards when we get into probability. This is called an outcome table. Okay, an outcome table is where we list all of the possible outcomes, and it's just a way to kind of organize our thoughts a little bit. If I roll two four-sided die and I find the sum, okay, then my outcomes. So if I roll a 1 and a 1, I have a sum of 2. A 2 and a 2, a 1 and a 2 is a sum of 3. A 1 and a 3 is a sum of 4, and so on. So we can fill in this outcome table as such. Okay. So then it says write using set notation, all combos. Okay, in other words, which dice give me, I want all of the sums greater than 5, and the sums less than 5 using set notation. So we'll do that up here because it's going to take a little space. So for, this is B number 1, all sums. So that would be the universal set because it's everything. Okay, so the sums that I can get are 2, 3, 4, 5, 6, 7, and 8, but the question is asking me to write all of the combinations that provide those. Okay, so I can roll a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4. We are going to basically go through, so the 1 with all of these, the 2 with all of these, the 3 with all of these, the 4 with all of those. Okay, so you might want to pause the video now and just get all of those down. Okay, so there is my set of all of the possible combinations I can get when I roll a dice. Okay, then the combinations that will give me a sum greater than 5. Okay, so greater than 5, and we're going to use F to represent that set. So this will be number 2. So my set is F. I guess I should have an equal sign there. So F is sums greater than 5. So sums that are 6, 7, or 8. So I want to give the combinations that give me that. So to get this 6, that is a 2 and a 4. So I can get a 2 and a 4. I can get a 3 and a 3, a 3 and a 4, and then those 3 scenarios where I start with the 4. So I've got a 4 and a 2, a 4 and a 3, and a 4 and a 4. So that is essentially these 6 outcomes there. Give me a greater than 5. And then I want to do sums less than 5. Okay, so less than 5 are these guys here, those 6, and we'll use L for that set. So I could have a 1 and a 1, a 1 and a 2, a 1 and a 3, a 2 and a 1, a 2 and a 2, or a 2 and a 3. Nope, sorry, a 3 and a 1. Back that up. This guy over here is a 3 and a 1. Okay, so that is all of my set notation. And then I want to display that information using a Venn diagram. Okay, so I'm going to make my Venn diagram here. Okay, so my universal set here. Then I have to, when I'm setting up my circles, I have to decide if there's any overlap between. So is it possible to be both a sum greater than 5 and less than 5? Nope, it's not. So that means I have disjoint sets or circles that are opposite from one another. One of them is the sums greater than 5. One of them is the sums less than 5. And basically I put my numbers in to each. So my sums greater than 5 are 2, 4, 3, 3, 3, 4, 4, 2, 4, 3, and 4, 4. And my sums less than 5 are 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, and 3, 1. And then any sums that have not yet been accounted for, well, those would be the ones that are exactly 5 from my chart. So the ones that give you exactly 5 would be a 1 and a 4, a 2 and a 3, a 3 and a 2, a 4 and a 1. Okay, so you've got those 4 that will give you exactly 5. So that is my Venn diagram. And then when it says, are there any that are mutually exclusive? Remember, mutually exclusive means that they cannot occur at the same time. They are disjoint. So F and L are mutually exclusive. Okay, now down at the bottom, just a quick review. So N is the number of items in our universal set. So really you could look back to your outcome table, count them there. You could count them in your universal set notation. You could count them up in your Venn diagram. These are all just different ways of saying the same thing. So the number in the universal set is 16. How many of those are greater than 5? So if you look in the here, you can just see this one. So there are 1, 2, 3, 4, 5, 6 elements that are there. So that is 6. The number that are less than 5 is also 6. The number that are not less than 5 is what that says, right? The complement of 5. So that would be 16 subtract 6. The whole, take away those that are in there. So that'll give me 10. And I'm not really sure what I meant by this question because I don't even have a set E. So we'll just get rid of that guy and we'll call it a day. All right, so you can go ahead and practice. Again, it's just counting up the number using an outcome table, set notation, Venn diagrams, just practicing those because we are going to be diving into a little bit more complicated questions and we need to make sure that you're comfortable with all of that kind of notation.